In this video, we're going to be looking at topic 2G, acids, bases and salt preparation for the IGCSE chemistry course from Edexcel. We're going to be focusing on the triple content, so looking at how we form insoluble solids. If you want to look at double content, please feel free to check out that playlist on this channel. So for the triple content for salt preparation, we're looking at how we can prepare a soluble salt sample that is pure and dry, starting from an acid and an alkali, and this is linking it to titrations. So this would be for your sodium, potassium or ammonium salts. And we also want to know how we can prepare an insoluble salt from two soluble reactants, and there is a practical that goes along with this as well. So sodium, potassium and ammonium compounds are all soluble in water. This means because they are soluble, we cannot filter off the excess solid the way we would if we were making something like copper sulfate, because all of our substance or all of our salt would all dissolve into the water. So we have to use a different method in order to make this soluble salt in comparison to the methods that you met in double. And the way that we do this is we use a titration method. So we will usually use sodium hydroxide, potassium hydroxide or ammonia as our bases, but sometimes we may wish to use the carbonates of these ions as well. It just depends. Now the titration method we already covered in topic 2F, acids, alkalis and titrations, but you know that it will allow you to calculate the exact amount of acid and required to neutralize a substance. So it is a very accurate method. So what we do is we carry out the titration and we see exactly how much acid is being required in order to neutralize the reaction. But the biggest problem is that this method includes an indicator, because you have to be able to see when you have actually neutralized your alkali. Now the problem is we do not want the indicator in our sample because we want a pure sample. So if we have the indicator, that is going to be an impure sample. So we carry out the titration with the indicator, get the volume that we need, and then we repeat the titration, this time without the indicator, and that ensures that we have our pure solution. So let's look at an example of how to make sodium sulfate. So we're going to have sodium hydroxide added into a conical flask, and we're going to use a few drops of a methyl orange indicator. We're then going to use our sulfuric acid in our burette, and we will carry out the titration until we see a colour change from yellow to orange, and this is when the substance is neutralised. So we have reached our end point when we see that colour change. Now, of course, we repeat the titration, this time without the indicator, and this will form a pure sample of the salt. But again, that is still going to be in an aqueous solution because we're forming our salt plus water. So what we need to do is we need to remove that water. So we're going to heat the solution to boil off some of the water, not all of it, because we want to concentrate the solution or make a saturated solution. Once the solution is concentrated, then we take it off the heat and we allow it to cool, and that allows our crystals to form. Once the crystals are formed, there may still be some liquid left over, so we have to filter the solution to remove the crystals and get rid of any of our soluble impurities that may have been present, and then we will dry the crystals in an oven. And the oven should be a warm oven, not a hot oven. If you say hot, you're in potential of melting your crystals. We just want to have a little bit of warmth just to remove any water. So the formation of this solution is going to be as follows, where we've got our sodium hydroxide reacting with our sulfuric acid to make our sodium sulfate. And then as we crystallize the sodium sulfate, we're going to have the water of crystallization in our equation. So this just means that the water is going to attach onto the sodium sulfate molecules. You don't need to know how it does this, but this then allows you to form your crystals. And you can see that when this happens, we get this solid state symbol as opposed to our aqueous solution. Now, sodium chloride is another soluble salt that we can make in this exact same way. The only difference this time is that we would use hydrochloric acid instead of the sulfuric. We can also form ammonium sulfate crystals using ammonia solution and sulfuric acid. The only difference in the method is that the crystallization should be carried out slowly rather than evaporating to dryness the way that you may with any other soluble salt that you've covered in double. So we want to make sure that we're carrying the crystallization out very slowly, and that is going to give us nice large crystals as well. Now, the method for making an insoluble salt is different to that for a soluble salt. But the basic procedure involves mixing two soluble salts to form this one insoluble and a solution of a soluble one. And we call this a precipitation reaction. So what does that actually mean? Well, let's look at an example. We want to form insoluble silver chloride. Okay, so what we do is we mix silver nitrate and sodium chloride, which you can see here. Both of these are aqueous solutions. These two aqueous solutions are then going to mix and we're going to form a precipitate, so our solid silver chloride, and we're also going to form our aqueous sodium nitrate. So we are getting a bit of a displacement reaction here with the sodium wanting to react more with the nitrate ions. And let's explain that a little bit further. So the attraction between the ions in the solutions, so when you have your aqueous solutions, are not strong enough to make the ions stick together. So these ions dissociate from each other. So they move around within our liquid solution. So we've got some sodium ions, some nitrates, some silver and some chloride just moving around within our solution. And there is some attractions, but they are not attracted enough in order to stick together. When the two solutions meet, the ions mix with one another. The attraction between the silver and the chloride is so strong that it actually causes them to clump together and they form a solid. So here we've got weak attractions between our ions. As soon as we mix them, we are going to get very strong attractions between our silver and our chloride, and they're going to stick together to form the solid silver chloride. Now, the sodium and the nitrate, they've got an attraction to each other, but again, this is a weak attraction. So they actually just stay in solution. Because although there is an attraction, they are similar to what we had at the start, that it's not strong enough in order to stick them together. Whereas for the silver and the chloride, the attractions are strong enough to stick together. Now, when we're making insoluble salts, we need to make sure that we mix the correct solutions of soluble salts, because we need to ensure that the substance that we're going to get is going to be a precipitate. So we need to be confident in using our solubility table. And we will look at the solubility table in just a few minutes. So two key facts that we know from our double studies is that all nitrates are soluble and sodium and potassium salts are soluble. So if we mix a nitrate of our insoluble salt with a sodium or a potassium, we're going to make a soluble solution. So we may be able to then form an insoluble salt that will be in that solution. So let's have a look at an example. And this is a practical that you can be asked about, in particular in your exam, and it is how we form lead to iodide. So our metal is lead. Now we know that the nitrates are soluble, so we want to use lead nitrate, and this is going to be an aqueous solution. The non-metal is iodide, Again, we know that sodium salts are soluble, so we're going to use sodium iodide. And again, this is aqueous. But when we mix these two things together, the sodium nitrate, yes, that's going to remain aqueous, but we're going to form this precipitate of lead iodide. And you can see that the precipitate is here. It is this yellow solid being formed. Now, barium sulfate can also be made, which is a precipitate, and you actually use this in topic 2H chemical tests. We use this as the test for sulfates, and we can do that using barium nitrate and potassium sulfate, and we can also make lead sulfate from lead nitrate and sodium sulfate. So you can see each time forming a precipitate and an aqueous substance. This is how we form that insoluble salt. So let's have a quick look at our method. We take 25 centimetres cubed of our lead nitrate and we add it to 25 centimetres cubed of our sodium sulfate, and we're going to get a precipitate of lead sulfate being formed, and this time the precipitate is white, so not quite as bright as the lead iodide, which has got that vibrant yellow colour. Now again, what we have here is we have our lead sulfate in a solution of our sodium nitrate. So we need to separate these two. So in order to separate, we filter the solution in order to remove the lead sulfate crystals. And the white residues sometimes might have some excess reactant, so we may have some of our lead nitrate or our sodium sulfate left over. So we wash it with distilled water, and this just removes any of the impurities. And the same as our soluble salts, we always want to make a dry sample. So we put our filter paper and we put it into a warm oven just to dry out the crystals and remove any of our water that may be there. So just to summarise how we make salts, if the salt is insoluble, we are going to use our precipitation method. So an example of that would be if we were making lead sulfate. Is it a sodium, potassium, or ammonium salt? If the answer is no, then we're going to react the acid with an excess of a metal oxide, hydroxide, or carbonate. So that is the double content, and that would be if we were making something like copper sulfate. Or if it is a sodium, potassium, or ammonium salt, then we're going to use our titration method, and that's where we might use something like that to form sodium sulfate. So you can see, depending on what the sulfate is connected to will depend on what method you use. So it's extremely important that you do know your solubility table. So let's have a look at a past paper question. So for 4 marks, describe how you would use the method of crystallization to obtain a pure dry sample of ammonium sulfate from a dilute solution of ammonium sulfate. Okay, so we've done our titration and we have formed our solution, and now we want to get the crystals. So for 4 marks, we're going to need 4 different parts to this. So the first thing that we're going to have to do is we are going to heat the solution until the crystals start to form. And then this tells us that we have a saturated solution. And we can test this using a glass rod. So we can dip a glass rod into the solution, and once we remove it, if we see crystals forming, then we know we have a saturated solution. Once we have our saturated solution, we then cool to allow the crystals to form. Now, you don't have to specify a time limit for this. You just simply have to say you have to cool or to leave the solution in order for the crystals to form. Then we need to separate the crystals from anything that is left over. So we have to filter to obtain the crystals. And then the fourth part, of course, we always have to dry the crystals. So then we dry in a warm oven, or we could even use filter paper. And we can blot them dry or pat them dry using filter paper. So there's your mark scheme. So mark 1, heating or boiling to ensure we have a saturated solution, then leaving it to cool, filtering to get the crystals, and then a suitable method of drying. So let's have a look at another question. So we've got soluble salts being able to be formed by reacting an acid with a metal hydroxide, metal oxide, or metal carbonate, or insoluble salts can be made using a precipitation reaction. We want to complete the table to show which acid or metal compound is used, and then state whether we use it in a solid or aqueous solution. So of course, all of our acids are all going to be aqueous. The metal compound may be aqueous, or it may be a solid. So if we formed the salt copper sulfate, we must have used sulfuric acid because we have formed a sulfate salt. And we've used copper oxide reacting with that sulfuric acid. And the copper oxide that we use is going to be a solid. So that is in the double content. So make sure that you are confident with that. If we have formed silver chloride, we've used a hydrochloric acid, and we've used an aqueous solution of a silver compound, and the most common one that we would use, because there's not many silver compounds that are soluble, would be silver nitrate, because then we're going to form our silver chloride and our salt. If we form potassium nitrate, well, because it is a nitrate, we must have used nitric acid. And we've used potassium carbonate. Potassium carbonate is typically used as a solid, but you can sometimes use an aqueous solution. Either one of them would be accepted. And then we want to look at, for 5 marks, lead chloride is an insoluble salt that can be prepared by reacting lead nitrate with sodium chloride. Describe how you would prepare a pure, dry sample of the lead chloride by starting with these two substances. So how are we going to do this? Well, because it is an insoluble salt, this is your precipitation reaction. So we're just wanting to describe, for 5 marks, how we get a precipitation reaction. So the first part, we're starting from solid lead nitrate and solid sodium chloride. So we have to dissolve the solids to form their respective solutions. So this is where you're going to have them separated. So you're going to form lead nitrate, aqueous, and you're going to have sodium chloride, aqueous. So we have to dissolve the solids first of all. The second thing is then we have to mix the two solutions together to form the precipitate. And that would be our precipitate of lead chloride. Of course, then we have to separate the precipitate, so we have to filter to remove the lead chloride crystals. Now, sometimes they may be covered in some of our reactants, so we have to wash the solid lead chloride using distilled water. And then the last part, always dry the sample in a warm oven. So for our precipitate, we have to have our two solutions. We mix the two solutions, filter to remove our solid crystals, wash it using the distilled water, and then dry the sample in a warm oven. And you can see that we have our table and our 5 points. Ignore this part of the mark scheme, that was not in one of the questions. That's everything for topic 2G, salt preparation for the triple content. If you have any questions, please feel free to leave a comment below, and we hope to see you back on the channel soon.